Okay, Bismillahirrahmanirrahim. Let's continue to the next part, or the next questions of discussion question. So in number 4 and also number 5 until number 6, we will discuss the questions about periodic properties. Periodic properties of elements. Now, if you still remember, we have learned about this, so there are 3 properties of elements that you have to know. The first one is atomic radius, the second one is energy, ionization energy, and the third one is electronegativities. So this is the type of question that will appear in the examination. Now, I will write first, the first one, the first properties is atomic radius. The second one is ionization energy. And the third one is electronegativity. So let's go to the fourth questions. Number 4 is the ionization energies. For elements X, Y, Z, A, and B are known. And then if these elements are in group A, then the correct order based on this ionization energy values from top to bottom is what? Now, so by these questions, you will be provided by some data of ionization energies for some elements, and then you have to reorder or arrange the correct order based on its ionization energy. Because these elements are arranged by groups, because all of these elements are located in group 1A. This is the clue. The clue is like this. So you have to put the correct order from the top to bottom, because group is the order of elements, that ordered vertically, or from top to bottom. Now, so you have to reorder all of these elements from X, Y, Z, A, and B. And the questions and the problem is how we can order this. Now the clue is 2 of this. The first one is about the group. Correct. The order is starting from the top until to the bottom, and the second one is by the ionization energies. So you have to know about the trend. What is the trend of ionization energy? Ionization energies based on the groups. Based on the group. Now, if you still remember, you can check also the material that I have shared you at the classroom. That based on the group, from top to bottom, the ionization energies decrease, are decrease. Are decrease. Now, so you have to order the elements based on its ionization energy. So from top is the biggest, from the biggest ionization energies, and then becomes decrease until the lowest. So you have to find first, yeah, what is the biggest ionization energies from this data. Nah, it starts from element X, yeah. So this is the first, and then the second is element Z, yeah. The third is Y, okay, and the fourth order is B, and the smallest is A. Nah, so the order is like this: X, yeah, because the total of ionization energy is 520 kilojoule per mole. And then continue with Z, 496 kilojoule per mole. And then next is Y, yeah, 419. Okay, and then the next is B, yeah, this one, 403 kilojoule per mole, and the last one is A. So the smallest ionization energy is element A, yeah, kilojoule per mole. So this is the order of ionization energy in group 1A. Now, so the correct order is starting from X, and then Z, and then Y, B, and the last one is A. Yeah, because the ionization energy from top to bottom become decrease. Okay, so this is the answer of number 4. Alright, let's continue to the next questions. Nah, the next question is related with atomic radius, yeah, or atomic radii. So let's read first the questions. Now, the question is the number, the atomic radius of group 2A elements. Okay, we have a clue in group 2A, yeah. So the order based on groups, yeah, not based on periods. Okay, in group 2A elements, yeah, starting from beryllium until Ba, yeah, or barium, are randomly distributed in angstrom units, namely blah blah blah. This is the data, yeah, you can find, you can see, and then based on this data predict which one is the atomic radius of Mg, yeah, or magnesium, and explain your reason. Alright, so we have a mission, yeah, to find or predict the atomic radius of magnesium based on this data. Now we don't know, yeah, what is the atomic radius of magnesium if we don't understand the trend of atomic radius based on the groups. Now, in the previous questions we talk about ionization energies, but right now we talk about atomic radius. So what is the trend of atomic radius based on groups? Now, if you still remember, yeah, that based on groups from top to bottom, from top to bottom, the atomic radius becomes increased, yeah, or becomes bigger. R increase, yeah. Nah, R increase. Okay, so based on the group, yeah, this is the group 2A elements. So in group 2A elements, nah, we can order ya, starting from beryllium until barium. Now you can see in the periodic table that will provide it in the exam. Yeah, so it's starting from Be, and then after that is magnesium, and then there is also calcium, strontium, and the last is barium. Actually there is also radium in here, yeah, in the below of barium, but because in the questions it's only clue that group 2 elements only starting from beryllium until barium, so we just put 5 elements in here. And then, nah, the clue is the trend of atomic radius based on groups. From top to bottom, the atomic radius are increased. Nah, when the atomic radius becomes increased, so the size of atom becomes bigger, yeah. Nah, so the biggest one, yeah, of these elements is barium, yeah, and then the smallest one is beryllium. Nah, so you have to arrange, yeah, or order which one is the smallest atomic radius and until the biggest, yeah, until the biggest atomic radius. Okay, starting from the smallest, yeah, the smallest one, this one, yeah, beryllium. Beryllium is the smallest atom. Nah, the smallest atomic radius. Okay, so we can predict, yeah, that the atomic radius of beryllium is 1.05 angstrom, and then the second one is magnesium, 1.50 angstrom, and then we continue it with calcium, yeah, the third smallest is 1.8 angstrom, and then next is 2 angstrom, and the biggest is 2.15 angstrom. Now, so from this order we can conclude that magnesium has 1.5 angstrom, yeah, in atomic radius. Yeah, so this is the answer. Okay, and then the biggest is barium, yeah, the biggest atomic radius. And then explain your reason, yeah. So what is the reason? Because the reason is magnesium is the second smallest, yeah, that has an atomic radius, so we just put, yeah, which one of the data that has the second smallest atomic radius. So that's the atomic radius of magnesium, yeah. So the atomic radius of magnesium becomes 1.5 angstrom. Nah, that's the answer.